Welcome to the DIY Honda Garage channel. This presentation addresses the Diagnostic Trouble Codes, DTC P0966 and P0967, found in the Honda Accord models from 2017 to 2023. DTC P0966 indicates a low voltage in the CVT-driven pulley pressure control valve circuit, while DTC P0967 indicates a high voltage situation in the same circuit. The continuously variable transmission, CVT, uses hydraulic pressure to control the performance and efficiency of the vehicle. This problem is primarily electrical in nature, meaning mechanical issues within the transmission are not the root cause. Properly diagnosing and troubleshooting these codes is essential to ensure the vehicle operates smoothly. Each step, outlined in the guide, will aid in pinpointing the exact failure point, assisting in efficient repair, and restoring optimal function of the CVT system. DTC P0966 and P0967 specifically pertain to the CVT-driven pulley pressure control valve circuit. The CVT stands for Continuously Variable Transmission, which utilizes a series of pulleys and belts to deliver smooth acceleration without distinct gear shifts. The driven pulley pressure control valve is crucial as it regulates hydraulic pressure within the CVT, influencing how power is transferred from the engine to the wheels. Both codes point towards electrical circuit issues related to this valve, indicating either low voltage, P0966, or high voltage, P0967. Importantly, these codes do not indicate any mechanical faults within the transmission itself, but are exclusively related to the electrical integrity of the circuit. The affected components' locations typically include the TCM, or Transmission Control Module, as well as wiring and connectors between the valve and the TCM, which are vital for the functionality of the CVT system. Several factors can trigger DTC P0966 and P0967. Voltage irregularities can arise due to a problem in the electrical circuit, such as poor connections or frayed wires that can lead to low or high voltage readings. Damaged wiring might include shorts or breaks in the wires connecting the CVT-driven pulley pressure control solenoid valve and the TCM. Both DTCs could possibly indicate a faulty transmission control module, which may either send incorrect signals or fail to interpret voltage thresholds appropriately. It's crucial to systematically check these components during the troubleshooting process to determine the root cause of the issue. Each of these potential causes needs to be ruled in or out during diagnostics to rectify the identified problem effectively. When DTC P0966 or P0967 is triggered, drivers may notice several symptoms exhibited by the vehicle. Warning lights can illuminate on the dashboard, specifically the check engine light, indicating that the vehicle's onboard diagnostics have detected an issue. Drivers may also observe poor transmission performance, which could manifest as hesitation, slippage, or unusual shifting behavior due to inadequate hydraulic pressure in the CVT system. Furthermore, abnormal engine behavior may also occur as the vehicle's power delivery system struggles to maintain optimal performance in response to incorrect pressure signals. A thorough understanding of these symptoms is vital for a swift diagnosis and allows for the identification of the underlying electrical issue contributing to these codes. The first step in troubleshooting DTC P0966 and P0967 begins with verifying the presence of the DTCs. To initiate this process, switch the vehicle to the on mode without starting the engine. Next, use the HDS, which stands for Honda Diagnostic System, to clear the DTCs. After clearing, start the engine and allow it to idle for at least 1 second before checking again for any pending or confirmed DTCs using the HDS. This initial step allows you to confirm whether the DTCs persist or if the issue could potentially be intermittent. If DTCs P0966 or P0967 reappear, this indicates that the problem is confirmed and requires further diagnosis. If the codes do not appear, it may suggest an intermittent fault or intermittent wiring issue, prompting further inspection of connections and terminals involved. In the second troubleshooting step, the objective is to determine the possible area of failure. Begin by turning the vehicle to the off or lock mode. Disconnect the TCM 50P connector, which facilitates communication between the transmission control module and the CVT system. After the disconnection, measure the resistance between the designated test points. Test point 1 is the TCM 50P connector number 14, and test point 2 should be connected to a solid body ground. A measurement between 5.0 to 6.3 ohms indicates that the circuit is functioning correctly and points towards further diagnostics before considering replacing the TCM. If you receive a reading lower than 5.0 ohms, this signals a potential short in the circuit, leading to further investigations. Conversely, if the reading exceeds 6.3 ohms, it suggests an open circuit that needs addressing immediately. The third troubleshooting step involves checking for short circuits in the DNLS line. First, disconnect the CVT-driven pulley pressure control solenoid valve 2P connector to isolate the input for testing. Then, check for continuity between the specified test points. The TCM connector number 14 for test point 1 and body ground as test point 2. If continuity is present, it indicates that there is a short to ground in the DNLS wire running from the solenoid valve to the TCM, and this condition must be repaired immediately. On the other hand, if there is no continuity, it signifies that the DNLS wire is intact, allowing focus to shift onto potential faults within the CVT-driven pulley pressure control solenoid valve itself. Ensuring that detailed checks are performed at this stage is crucial for an accurate identification of the problem. During the fourth troubleshooting step, checks will focus on the DNLS-DNC plus line to ensure there are no open wires in the circuit. Start by disconnecting the CVT-driven pulley pressure control solenoid valve 2P connector, just as in the previous step. Measure continuity again, this time between the female terminals of the solenoid valve 2P connector, specifically number 2, and the TCM 50P connector number 14, marking test point 1 and test point 2 respectively. If continuity exists, that indicates the DNLS-DNC plus wire is functioning correctly, allowing progression to the next troubleshooting step. However, if no continuity is detected, it reveals an open fault that needs rectification. Repairing this would involve tracing and fixing the break in the DNLS-DNC plus wire between the CVT solenoid valve and the TCM, ensuring complete circuit integrity to restore functionality. The final troubleshooting step involves checking the DNC- line for continuity. With the vehicle in off or lock mode and the appropriate connectors disconnected, measure continuity between the CVT-driven pulley pressure control solenoid valve 2P connector, terminal number 1, and a solid body ground for test point 2. If continuity is confirmed, it suggests that the DNC- wire is functional, redirecting focus back to the CVT-driven pulley pressure control solenoid valve, which may require replacement of the valve body assembly. Conversely, if continuity is lacking, an open circuit exists that needs to be repaired. The repair may involve fixing the DNC- wire break between the solenoid valve and ground, or addressing any deficiencies in the ground connection itself, typically marked as ground G251. Achieving continuity here is vital for the CVT functionality. and restoring operational performance. After completing the repair steps, it is important to verify that the issue has been successfully resolved. Begin by rechecking for any DTCs using the HDS to confirm that P0966 and P0967 no longer appear. Following this, conduct a performance test of the transmission, ensuring that the vehicle operates seamlessly without any jerks or hesitations that could signify residual problems. Pay attention to the hydraulic pressure operations governed by the CVT, making sure that it stabilizes during varied driving conditions. If everything functions correctly, the repairs can be deemed successful. These steps confirm that any previously detected faults have been addressed effectively, ensuring vehicle safety and performance. Preventive maintenance can significantly reduce the likelihood of encountering the same issues related to DTC P0966 and P0967 in the future. Regular inspections of wiring associated with the CVT system help to catch any wear or damage before they develop into larger problems. Additionally, frequently checking and maintaining proper fluid levels within the transmission can enhance hydraulic function and help maintain overall system performance. Monitoring the transmission behavior during normal operation will also allow early detection of any irregularities, ensuring timely intervention. By implementing these preventive measures, vehicle owners can contribute to the longevity and reliability of the CVT system, reducing potential repair costs in the long term. In conclusion, understanding DTC P0966 and P0967 is critical for effective troubleshooting within Honda Accord models from 2017 to 2023. Both of these codes highlight electrical issues concerning the CVT-driven pulley pressure control valve circuit and do not point towards mechanical failures. Following the structured troubleshooting process outlined in this presentation will ensure accurate diagnosis and repair. By systematically checking connections, resistance, continuity, and performing necessary repairs, technicians can resolve the underlying issues. Keeping preventive measures in mind will further assist in maintaining the integrity of the CVT system and bolstering overall vehicle reliability. Mastering these aspects is essential for any technician specializing in Honda vehicle repairs. Please like and subscribe to the channel. See you next time.